Welcome dear students once again. Today's topic is shear force and bending moment. Let us consider a beam AB of length L. Here is a vertical load W on this beam. The shearing of beam will takes place by this force. The shearing of beam takes place, that is known as shear force. This shear force is denoted simply by a symbol, that is SF. In case of bending moment, if instead of shearing, bending will take place in this way. Length L, here is load W, and the bending of the beam, shearing will not take place, bending of the beam will take place, that is known as bending moment. In case of bending moment, this is addition of all the moments to the left or right of the section. Here it is also L by 2, here it is also L by 2. Now what is shear force? I will tell you what is shear force. Shear force is the algebraic sum of all the vertical forces to the vertical forces acting on the beam on either side of the section, on either side of the section is known as shear force, SF. Either side of the section means to the left of the beam or to the right of the beam, or we can simply say it is defined as the algebraic sum of forces active on either left hand side or in right hand side of the section. In left hand side or in right hand side of the section, that is known as shear force. Now what are the units of the shear force? The unit of a shear force is, it is simply Newton, or we can say kilonewton. In case of bending moment, now what is bending moment? I will tell you what is bending moment. Simply, bending moment is the algebraic sum of moments. Is the, here I have taken only forces, now there is a moment, force into distance. It is the algebraic, bending moment is the algebraic sum of moments of all the vertical forces, acting on the beam, on either side of the section, is known as BM, bending moment. Now units of this bending moment are, it is Newton meter, or we can say kilonewton meter. Now the another important point is, what are the sign conventions of shear force and what are the sign conventions of bending moment. During solving the problems we will need these things: sign conventions of shear force. What is the sign convention of shear force? Simply, here I will take the section of the beam. Here is left side, here it is right side. If in case of left side there is upward force, and in case of right side there is downward force. then the sign convention is positive. In the same way, I will take another section. If on left side, here it is right side of this. I have told you left side of the section or the right, either side of the section means left side or right side. If in case of left side, here it is downward force, and in right side it is upward force, then the sign convention will be negative. Same way, here upward force is positive, down is negative, sign convention is positive. Left side the force downward direction, in right side it is upward direction, the sign convention will be the negative. In case of bending moment, sign convention of bending moment. In case of bending moment, here in case of bending moment, here is the sign convention of bending moment. This will be the sign convention of bending moment. In this way, this bending will take place. Simply, clockwise, if left of the section, अगर हम यहाँ पर sectioning करेंगे simply in this way, if it is in clockwise direction in left hand side and anti-clockwise direction in right hand side, clockwise direction in left hand side and anti-clockwise direction in right hand side, then it is positive. Then it is positive. In the same way, if it is anti-clockwise, I will take here section of the beam this way. If it is anti-clockwise in left side and in clockwise direction in right side, then it is known as sign convention will be negative. Here sign convention will be positive and here sign convention will be negative. This one is known as sagging, bending movement, and this one is known as, when here is anti-clock negative, so that is known as hogging, bending movement. Hogging, bending movement. Now there are some things we have to follow, pointers. Some pointers should be kept in mind for drawing the shear force and bending moment diagram. These are the important points. Number one, if we draw, say for example, here I will take the example of a cantilever beam. If this is a cantilever beam, here it is a cantilever, I will put here load W, say here it is point A and now this is point B. This is point B. First point, length of shear force and bending moment diagram must be equal to the span of the beam. Here it must be equal to the span of the beam. This is shear force diagram. It is equal to the length of the beam. Shear force diagram. This will be equal to the length of the beam. Okay. So this one is positive. This is shear force diagram, simply shear force diagram, SF diagram. Number two, I will write down here length of shear force and bending moment diagram. Point is to be remembered. Diagram must be equal to span of B. Span of B. This is shear force. Now this is bending moment. This is bending moment diagram will be in this way. This will be the bending moment diagram. This is the bending moment diagram. Bending moment diagram. Here it is W. Here it is also W. Here is WL and here is 0. Number second point. Shear force diagram is drawn. Shear force diagram is drawn below the loaded beam, and bending moment diagram is drawn below the shear force diagram. Important point. Shear force diagram is drawn below what? Below the loaded beam, and bending moment diagram is drawn below shear force diagram. Important point. Another point is, for a cantilever beam, bending moment will be 0 at the free end. Here bending moment is 0. No distance. Load into distance. W into 0, that is 0. That means in a cantilever beam, bending moment will be 0 at free end. In case of SSB, simply supported beam, it is 0 at the end supports. In case of SSB, bending moment will be 0 at the end supports. Another point is, calculate. Here I have put only one load, one vertical load. It may be so many vertical loads. Calculate all SF, shear force and bending. Calculate shear force and bending moment at all critical points. If no load is present between 2 points, if no load is present between 2 points from here to there, if no load is present between 2 points, shear force will be constant. Shear force will be constant, but this bending moment will be in inclined direction. So now, inshallah, we will talk about solution of the numericals about the shear force and bending moment in next video.